Welcome everybody, this is a nice question. Let me draw the figure. So we are expected to find the area of the shaded region. Now area of the shaded region will be from the area of the quarter circle. I will subtract the area of the two semicircles, right? So let this be semicircle S1 and semicircle S2. Area of semicircle S1 minus area of semicircle S2. So that is going to give us the area of the shaded region. So foremost, we can get the area of the first semicircle. So area of S1 is a semicircle, so it's going to be pi r squared over 2. The diameter is given as 8. So my radius is going to be 4 units. So 4 into 4 divided by 2. 2 divides here, 2 times 2, 4s are 8. 8 pi square units. That is the area of this S1. And we need to get the area of S2. Now I do not have the area of S2. So I'm going to take this as some radius r. So let this be Q. So QC, I'm going to take it as some r. Now there is a point of tangency. Okay. Now we have a theorem. Okay. Let's call it the radical axis theorem. Okay, a line drawn through the point of tangency between two circles will pass through their center. So this line will actually, if I'm just taking this as the point of tangency. So if I were to pass through the point of tangency, then that would connect the two centers Q and P. Okay, the centers are connected. Now I know this as a 90-degree angle. Now this, if I were to take this as say some r, point of tangency as r, RP is 4 units, and then what have I got? QR, probably, okay, does not matter. So QR is taken to be as r. So this means QP will be r positive 4. Okay. So consider triangle. Okay. If I were to consider this triangle POQ, okay, POQ, then by Pythagoras theorem, OP squared. So if I were to take this as 4, and this distance is r, right? But this entire distance or this entire length is 4 units, and I want to get this distance. So this is also r, right? So this length is going to be 4 minus r. So OP squared plus OQ squared is equal to QP squared. So OP squared is going to be 4 squared, that's 16. This is going to be 4 negative r squared is equal to this length. This length is r, this distance is r, this distance is 4 positive r. 4 positive r squared. So I need to expand this. So let me use this part of the space. 16 at 16 positive 4 negative r squared is equal to 4 positive r squared. So we will have to find the value of r. So this is 16 negative 8r positive r squared. There's already a 16 there. 16 positive 8r positive r squared. R squared gets cancelled. Now you move this 8r to that side. 8r plus 8r. Move 16 to this side. 16 positive 16 negative 16. They get cancelled. So this is going to give me 16r is equal to 16. So therefore r is equal to 16 over 16, which means r is equal to 1 unit. Okay, I'm just checking if everything is fine. Okay, that appears to be. So r is equal to 1 unit. So if r is equal to 1 unit, so what is the area of this semicircle? So area of S2 is pi r squared over 2, which is nothing but pi into 1 squared over 2, which is nothing but pi over 2. So required region is nothing but from the quarter circle. Now we need to get the quarter circle's area. So area of the quarter circle, the radii of the quarter circle is 8 meters. Right, this entire thing is 8 meters. So area of quarter circle is pi r squared divided by 4, which is nothing but 8 into 8 times pi divided by 4. 4 divides here 2 times is 16 pi. So what we have to do is required shaded region, area from the quarter circle. We take away the two areas. So this is 8 pi. 8 pi is one region. And this 16 pi over 2 is in another region. Pi over 2. Okay. So 16 pi negative. I take LCM as 2. This is 16 pi plus pi, which is 17 pi over 2 negative 16 pi. This is 32 pi minus 17 pi divided by 2. From 32 you take away 17, you get 5, and then from 2 you take away 1, you get 1, 15. So this is 15 pi over 2, which means 7.5 pi square units. So this is the required shaded area. Okay, please go through this question. Please like, share and subscribe. Thank you.